Good morning, fellow programmers. Thanks for joining me. I'm T-Pain. Yeah. And welcome to Let's Learn C++. Feel free to use the skip ahead feature on the right hand side to jump to any specific sections. Make sure to have annotations turned on so you can see any updates I make to these videos. I'll be using Visual Studio Community Edition, which you can download from visualstudio.com. However, you can follow along with whichever program or IDE you like. Today's focus will be on the GitHub exercises included in the previous lessons 8 through 14. If you had no idea about GitHub, check it out below in the description. Come on, do it. Peer pressure. Alright, so let's dive right in. Exercises for video 8 were not included because it was just covering simple GSL and library stuff, and exercises were not included for lesson 12 because that was actually about the practice of debugging. So neither needed exercises. Alright, so with that said, let's go ahead and dive into lesson 9. Alright, the first exercise says create a function called times10 that takes an int as a parameter and then returns the product of it times 10, no references or pointers. And here we go. We've just got a simple times 10 function using int as the return type, int as the parameter, aka the argument, and then we're just returning that times 10. Simple as that. And here we go ahead and try it out. Number 2 says create a print function that takes a string with default parameter of ham and simply prints out the value of the string. Okay, so we have a simple function here called print. It has the default parameter set to ham, and then we just use a simple stout statement to print it out. And here below we tested it. Exercise 3 says create a multi-array function that takes in a pointer to an array, the size of the array, and a double called multiplier. Create a loop within the function that multiplies every value in the array by the multiplier. Okay, and we start out up above with creating a function that returns nothing, that just says multi-array, takes in a parameter of a pointer to an array, or just an array, another parameter that takes in a size, and a third parameter takes in the multiplier we are going to be altering the array by. Then we have a simple for loop that iterates through each item of the array and multiplies it. Perfect. And then below we have a simple test case to test out if this is working. And if we run it, everything is working just as intended. We pass in 2 and 6, multiplied by them by 10, and then 20 and 60 are output. Perfect. Number 4 says create a combine arrays function that takes in 2 pointers of arrays of the same size and a parameter for the size. Create a loop that adds the second array to the first and then sets the second's values to 0. So here we have our function definition where we define this combine arrays function and then pass in an array here, an array there, and pass in the size for the arrays by combining them into the first array, setting the second array to 0. And that's it. Down below we go ahead and test that function, and if we run it, we will see that it works just fine by passing in 1, 2, 3, 4, 5, and 6. Results in 5, 7, and 9. Perfect. Alright, and now we'll move on to solutions for lesson number 10. Number 1 says create a function that takes an array as an argument using square brackets. So up top we've created a sum function right here, and then we just have parameters of int array with square brackets right here, and here we're just going to output the first element of the array just to make sure that we can actually access it. And if we run it, indeed, it does just output 1, which is from our demo array right down here. Perfect. Number 2 says create a function called add1 that is declared before the main function and defined afterwards. It takes in an int value and returns an int value of 1 more, then is copied in. Alright, so up top we have our declaration of the function called add1, and down below we have our implementation, or our definition of add1. And all it's doing is just taking in a value, and then adding 1 and returning it. Perfect. Number 3 says create a function called add2 that is declared in a header file and then defined in a separate CPP file from the main CPP file. It has a reference int parameter that adds 2 to it. Nothing is returned. Okay, so here's our main file, and here we're including the newly created add2 header file, and here we have our simple function call to add2 function, and then we're just going to go ahead and output the variable that's being passed in to make sure that the reference operator is working correctly. Now if we right click, we can actually go to definition right here, or we can go to declaration. So I want to go to this declaration first. So click on there and it'll take us to that header file. And here we have just our simple function declaration right here with no return type and just a reference value being passed in and the function's name. Now, if I want to, I can actually right click and then just go to definition, and then Visual Studios will take me right to it. And here is our actual implementation. We're taking in a reference value and we're just adding 2 to its original value and storing it within it. Perfect. If we go ahead and run it, we will see that it works just fine. Passed in 5 and it added 2 and now it's 7. It worked. Number 4 says create macros for a char, a negative int, and a negative double. And here we have them right declared up above, and then we just simply output each of those. Just that simple. Number 5 says repeat number 3, but enclose it all within a namespace called shakalaboom diddy boom. All right, so here we have our namespace of shakalaboom diddy boom, and then we have our add2 function being called from it, and we're just passing in x as before. Everything is pretty much the same. So now if we go to its declaration right here under go to declaration, in our header file we just enclosed everything within the namespace of shakalaboom diddy boom. All right, and then we can right click and we can always go to definition, and it'll take us right to that. And here is our implementation of that function. And we're just including the header file so that everything connects up properly. Boom. Number 6 says create a function called print sandwich, and that returns nothing and does indeed print sandwich. Nest that function within 2 namespaces called cheese and bologna. Then create an alias namespace called Belize. That's a combination of bologna and cheese. Whoa. And use it to call print sandwich. Cool. So here we have our print sandwich function that just prints out sandwich, and we're storing it within a double namespace of cheese and bologna. And we're creating our own namespace called Belize, and we're setting it equal to the double namespace of cheese and bologna. So Belize is called, and then we call print sandwich, and everything is hunky-dory. And that's it for lesson 10. And now we're on to lesson 11. Create const variables for int, char, string, and double. All right, and here they are. Ta-da! Const. That's all you need to do, is just throw it in front of the data type and everything is good. Number 2 says create const pointers for int, char, double so that the address cannot change. All right, so we're just going ahead and create int I1 and int J1 and setting those to 2 separate values. Then we're creating a pointer that is going to be constant. In other words, it cannot point to any other address, and set it equal to I1. Then down below, we're going to go ahead and change the value of I1, and notice it does not give us any compiling errors. This is because the address is not actually being changed, and I1 is not declared as constant up above. Only the pointers to that specific address. If we uncomment this line right here, it gives us a compiler error of saying that I, const I, this one right here, this constant pointer, cannot be changed to another address. That's just what we would expect. The const is working perfectly at keeping this pointer restricted to pointing to just this address. And then down below, we implement those for the char and double. Perfect. Exercise 3 says create an inline function that takes in a const int reference, has a precondition of it being greater than 0, and returns 5 more than that value. All right, so here we have just tacked on the keyword inline before our function is defined. We have a return type of int, we have my function, we have a value being passed in, and then we make a call to the GSL function called expects, which is basically just an assert. And if this topic is unfamiliar with you, if the GSL doesn't make much sense, or this guy, then make sure to check out tutorial 8 that covers GSLs. And here we have just a simple call to this function by passing in 5. If we pass in 0, it'll raise a breakpoint error, and our code will be halted at the expects. Perfect. Number 4 says create a const int const pointer set to 5. So here up above we have an int called I set equal to 5, and then another int called j that's equal to 0. And then we create our const int pointer that cannot change its address because of the second const. And we set it equal to the value of i's address. So we can actually change the value of I because it is not const. However, we cannot change the value at that address through the pointer p. And if I uncomment these 2 lines down below, you'll see underlines saying that. So we cannot set the pointer p to another address because of that second const, and we cannot change the value that the pointer is pointing to at that address because of the first const. Cool. Number 5 says create an inline function that takes in a const string const pointer and has a postcondition that ensures the string is not empty. Okay, so we just have an inline function here, and that's going to return nothing. It takes in a const string pointer that is constant, and then calls to ensure, which is again a part of the GSL library, to make sure that the value at that address is not 0. And here below, we do a quick check to make sure it's working, and we pass in a new string, and we'll cover the keyword new in one of the coming tutorials very, very soon. But we're just passing in the string of ASDF, and if we run it, indeed, it works out just fine. No errors or anything. However, if we uncomment the previous line, we will see that it will trip that ensures and break the code right there, which is exactly what we'd expect. Perfect. Number 6 says create const expression variables for int, char, string, and double. Now this one was actually kind of a trick. I didn't mean for it to be harder than it was, but I had forgotten that string is not an actual regular data type like int and char and double are. And so when you try to throw const expression in front of them, all these guys work just fine. It's pretty much the same as const. However, const expression does not actually work with strings. Instead, if we want the same effect, we just go ahead and use the keyword const, and it'll work just fine. Cool. Number 7 says create a function that creates a const expression variable within it, but does nothing with it. And here it is. Brr. Number 8 says create a recursive function that removes a letter from a string and then returns the reverse of the string. There was 2 ways you could have done this, and they were both kind of tricky. The first way, and this is the more complex way, but if you know less about strings, then this would make more sense. So this way is we're using the string's length to grab the last item of the string, or the last character of the string. And so we're just saying, hey, grab the last character of the string and store it in C, okay? After that's done, we're gonna go ahead and resize this whole string to be 1 less than what it currently is. And so that'll shrink it by 1. So we've successfully grabbed the last item and shrunk the string by 1. And then we go ahead and return the reordered pair. So we grab the last item, we put it in front, and then go ahead and call the same function on itself. The other way you could have done this is by using 2 separate functions built in the string called back and pop back. So back just simply gets the last character of the string. It's just one of those built-in functions that's really nice to use. The second function is called pop back, and it just removes the last character of the string. So then after we've done that, then we just go ahead and pass in C, and our last line stays exactly the same. So I'm sorry I haven't quite covered those functions built into string enough to make this 100% clear, but I wanted you to be forced to do a little research on your own to discover this. Oh, and one last thing I forgot is that we start off our function with the condition to break the recursive loop, and we just have our string length checked to see if it's 0, and if it is 0, then we just go ahead and return the string up. And so that's what will cause our string to build back up through all these function calls. And if we go ahead and test it out, we have a string called finger licking good. Go ahead and run it, and we have our string being returned back in reverse order. Finger licking good. Cool. And now for the last exercise, exercise number 9, create an overloaded inline function for subtracting 1, 2, and 3 numbers away from the first number passed in. And here we have just that. We have this function that is going to be overloaded because there's going to be multiples of them that just has a different number of parameters being passed in. If I scroll over to the right, you'll be able to see that they are all just adding on an additional number to subtract from A. So we have A minus B, then A minus B minus C, and so on and so forth. And down below, we just go ahead and check it to make sure that it's working. And here is the output, 9, 7, and 4, which means that 1 minus 1 and 2, and 1, 2, and 3 are all being subtracted from 10. Perfect. And that's it for lesson number 11. And now for lesson 13, exercise number 1 says create an enum of flowers and then create a switch that prints out what each is. So here we have our enum, and we're just creating poppy, daisy, rose, dandelion, and daffodil. And then here we have our flower printer. This thing will crush flour into tiny, tiny little grains that we can sprinkle over bread or make bread with, or no, that's a terrible joke. All right, so flower printer is just going to take in an enum of F, and then we're gonna have a switch statement that outputs what each one of these is. So if you're passing in a poppy, it'll print out poppy, daisy, rose, daffodil, dandelion, etc. And we have a default that says if it's unknown, then it'll print unknown, kill it with fire. All flowers that are unknown should be killed with fire. Okay, and then we just go ahead and test our function by passing in a copy. Perfect. Exercise number 2 says create an enum of first names with the first being set to a value of b. Then create a variable instance of each. All right, here's a random sort of names that are in no way related to my coworkers or people I work with. All right, so our list of names includes Alan, Brett, Chris, Dan, and Ellen. Simple enough. And then I just create instances of each of those as variables. And then I output a just to test it. Perfect. Number 3 says create an enum class of vegetables and another of breads. All right. So for our enum of vegetables, we have celery, carrot, lettuce, garbage, fingers, and a car. These are all really well-known vegetables. Next, we have our bread, which is wheat, cinder block, brick, and enriched uranium. If there's a peanut butter and jelly you want to make, there's no better bread than enriched uranium. Okay, and that's it for these. Oh, and by the way, if you were looking on screen and did not see this keyword class, it was actually there all along. You just weren't looking hard enough. Alright, let's move on. Number 4 says use int a to output the ASCII values of a through g. So rather than doing this in 7 lines of code, I decided to do it in 3. Here we have our creation of an array of characters a through g. Then we create a simple loop to go through all 7 items and then output each of those to print out their ASCII values. And if we go ahead and print that out, there are those ASCII values. Cool. Number 5 says create a struct called fighter with an int called health and another int called strength. Create an instance with values 105. So here's our struct defined here. We create an instance of it called Tomothy, and we pass in parameters of 105 to set the health and strength respectively. Perfect. Number 6 says create a struct called dog with an int called fur that has a default value of 5. Then create a string called name. Create an instance, then set its name to Stanley. All right, so here we have our struct. We have our int set to a value of 5, and then our name. Then we create an instance of dog, and we set his name to Stanley. So Stanley is named to set Stanley, because it was spelled wrong or spelled right, I don't know. And that is it for lesson number 13. And now for lesson 14. Exercise number 1 says create a class for 3 different variables with an int called fiber set to different amounts. All right, so here we have 3 different vegetables. We have a vegetable called carrot, and it's set to fiber 4. We have celery, which is set to fiber of 10. And then we have laxative, which is set to a fiber value of 300,000. Because we all know that laxatives have the most fiber value. Nothing cleanses you better. And then we have instances created of each of those, and then a test output for it, just to verify it's all working. Perfect. Exercise 2 says create a class called fighter with 2 private double member variables called health and attack. Create a public constructor that sets each to 50. Create a public function called printinfo with void return type and no parameters. Then have it print out the health and attack. Create an instance and test the function. All right, so here is our declaration of the fighter class. We have 2 member variables that are doubles called health and attack. In the constructor of the class, we set the values each to 50, and then down below we have a member function called printinfo, and then it just outputs each of those respectively, health and attack. Finally, we create a fighter called random goon, and we call the printinfo to make sure that everything is working. And if we run it, indeed we see health at 50 and attack at 50. Perfect. Finally, exercise number 3 says create a class called unicorn spottings with a single private int called count. Then create 3 public functions called getCount, add spottings, and remove spottings. Return types and parameters should be appropriate. Create a pointer to a class instance and test output each of the function's results. So up above we have our class unicorn spottings created, and we have count. Then we have our public function called getCount because all of our initial stuff is defaulted to be private, so this count is private. So we have our public getCount, which just returns count. We have our add spottings, which takes in a parameter of int num and then adds that value to a count. Then we have remove spottings, which takes in another number, and it subtracts that number from the count. And so we go ahead and test that stuff out down below. We create an instance, then a pointer to the instance, and then we call these functions from the pointer, calling getCount, add spottings, getCount, remove spottings, and then finally to getCount one last time. And if we run it, we will see 0, 4, and 2. So what happened was the unicorns were initially talked about, then 4 people spotted them, and then 2 of them were actually liars. All right. So that is it. Thank you guys so much for watching. Please leave me a comment below if this helped you, and also check out the comments if you're having problems. Please share this tutorial series with someone special, and maybe support me on Patreon. Meh. Thank you so much for your support, and as always, like, subscribe, and keep the dream alive.